Let us talk about the C++ classes and object-oriented programming principles. So what is a class? A class is basically a user-defined blueprint for creating objects. It defines a skeleton for creating the objects. It groups different data members and member functions. Data members are attributes, which are also called the variables, and member functions, which are also called the methods. So what an object can do, for example, if I take the example of a car, the model of the car, color of the car are the data members or the variables. Whereas driving the car, you can drive a car, you can increase the speed, accelerate. So all these are the member functions or methods related with the class. A class is a concept which is supported by object-oriented programming. Now, the principles, there are four basic principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation means wrapping up your data and methods in a single unit. So, in C++, if we are going to define a class like car, so first we define all its members like private. Private means the access is only within the class. These members cannot be accessed outside the class. So private, like string color. This is the private member. And in the public section, we define the attribute functions, methods of the class. So wrapping up of data and behavior in a single unit is called as encapsulation. Now, the second concept comes of abstraction. Abstraction is hiding implementation details from the user. For example, if we are working on a mobile phone, we taps the number, we tap the call button and we call. We are not familiar with the details, implementation details, that how it is implemented, how my call is taking place and everything. In the same way, if we in a car, if we start the car, it starts. We are not considered about how is engine is performing the actions, how is car is starting. We don't take care about it. So all these are the abstraction, that is hiding the implementation level details or the complex details from the user. That is the abstraction. Then inheritance. Inheritance is one of the most important concept of object-oriented programming. It is reusing properties and behavior from another class. Like for example, we have defined some behaviors and properties for one class. We can inherit that class to reuse them so that we do not need to declare and define them again and again. So inheritance gives you a concept of reusability and specialization. Then comes the polymorphism. Polymorphism. Poly means many, morph means forms. So many forms. Polymorphism gives you a concept of many forms. Like one operation can behave differently under different circumstances. Just for example, if I'll say 2 plus 3, if I'm using the plus operator on integers, it is going to give me the result 5. But if I same use this number addition 2 with strings 2 and 3, it will give me the result as 23. It will concatenate the values, right? So this is called as polymorphism because this addition operator works differently under different data types. So this is basically a concept of function overloading and overriding, which we will cover later on. Benefits of using classes: code reusability, you can reuse the code. Once a class is defined, we can use it any number of times, and by using the inheritance also. Easier maintenance, since my code is divided into blocks into the terms of classes, so we can maintain each class separately. So it makes our code modular also in terms of classes, so it is easier to maintain. It provides us security by using the encapsulation. We define the getter setter methods, we define the public and private members. So it provides us the better security and better modeling for real world entities. We can map the real world entities as it is in our coding. So it is a better modeling tool. For example, like class car, where a class is always declared with a lowercase letter c. Class car public, the public variables. By default in a class, everything is private. So to make them public, which means it can be used outside the class also, we use it as a public. String brand int year. So these are two data attributes of this class car. Then we are creating a method display, which will display the brand and year. And when we need to use this class in the main method, we will declare its object like car C, and then we will use it simply c dot display. We will need to use the dot operator to access the methods of class. So simply we will use c dot display. So it will call the display method of the class car for object C. Real world analogy. A class is like a blueprint of a house, and an object is actual house built from that blueprint. So multiple houses can be built from the same class. So same blueprint, like a same class, can be used to create any number of objects in a class. As we said, encapsulation is wrapping up of data in a single unit. For example, this one, the class student with a method private member age. Now, age is a private variable, so it cannot be accessed outside the class. So for this purpose, to provide the controlled access, we use getters and setters. Getters are used to return the value of a variable of a member, whereas setters are used to set or modify the value of a data variable, data member. So this is an example of getter. We use the word get, int get age. So it will just return the age. Void set age int a. This is a way to define a setter. The return type is always void. So age will be set with the variable a, which we are passing here. In terms of setter, we use the set before the method name. For getters, we use the word get. It is a journal terminology to define getters and setters. Constructors. Constructors are special methods which are used to instantiate an object as soon as it is created. Make sure always the class name and constructor name are same, even the case sensitive. Class name and constructor name are always same. A constructor does not return any value, not even void. Constructor should be public in nature, and there can be more than one constructors in a class, but their parameter list should be different. For example, we are defining here a class car. There are two again data members, string brand and int year. Now we are defining a constructor. So car string b int y, this is the constructor. So brand will be initialized with b and year will be initialized with y. So as soon as we are defining the class object car1 Toyota 2020, the brand will be initialized for the car1. The brand will be initialized with Toyota and year will be initialized with 2020. For inheritance, like car is a vehicle. We can define another class also, like motor. Motor is also a vehicle. Bike is also a vehicle. So all of these persist, all of these contains some common properties. Those common properties we include in one class which is called as parent class. Then, so this method, start method, is same for all the classes. Now, if we are defining a class car and we are inheriting it from the class public, then public, the class car has the method drive, but since it inherits the vehicle class, so all the public members of vehicle will be inherited to this. So if I write my car dot start. Look, since start is a method of vehicle, but since vehicle is inherited to the car class, the car can also use this method. It is also, now this start method is also available to the car method class. And my car dot drive, the drive method is of car class, so we can use it. This is an example of polymorphism of method overriding, in which we are creating a class animal which has the virtual void sound. Now, the dog class inherits the animal class. So, we are overriding this method. So, if we create an object A of animal type which consists an instance of dog, and we call dog, that is A dot sound. So, since A is an instance of dog type, it will output the woof because it is overriding the sound method. If you see, the sound method is in the animal class also, and the sound method is in dog class also. So the method of the dog class is overriding the method of animal class. Abstraction example, it is hides the details and shows only the necessary feature. So we are defining a class shape here, in which we are defining a pure virtual function. Pure virtual function is, it does not have its body here, but any of the class which inherit this shape class, they have to define this method draw. They need to override this method draw. So if circle class overrides the shape class, inherits the shape class, it has to override this method draw. Again, there is one more example for with getters and setters of encapsulation, like bank account, in which we are having a balance member. Methods are deposit, withdraw, and get balance. So get balance is the getter, basically, which is returning the balance, current balance. One more example of student class, where we are defining a constructor for the student with name and age, set age, setter, get age, getter. So we can use it. In the next video, we are going to discuss with his C++ matrices. Thank you.